In this example, we have an athlete twirling a large ball around his head. The ball sweeps out a circle whose radius is 0.65 meters. If the mass of the ball is 12 kilograms and the tension in the rope is 2.1 times 10 to the 3 newtons, the question is, what's the speed of the ball as it travels around the athlete's head?
Now, the math behind this problem isn't very bad. It's the concept I want to concentrate on. This athlete's twirling a mass in a circle. Since the mass is moving in a circle, there must be a centripetal force. You simply can't have motion in a circle without a centripetal force. But the question is, what's supplying the centripetal force? Well, the quick answer, of course, is the athlete is. Without the athlete, this mass wouldn't be moving at all. However, the athlete isn't really touching the mass, so he can't directly apply a force to the mass. There's something else that's applying the centripetal force. Well, the only thing attached to the mass is the rope. The tension in the rope is what's supplying the centripetal force. Look at the diagram. At the point where the rope is attached to the mass, which way is tension pointing? It's pointing in, towards the athlete, towards the center of the circle. That's centripetal force. Centripetal force causes circular motion and always points to the center of the circle. So the centripetal force in this case is the tension in the string,
2.1 times 10 to the 3 newtons.
Now that we've made this connection, the rest of the problem's not so bad. We have an equation for centripetal force. It's mv squared over r. Now, we've already decided the tension in the string is the centripetal force.
So Fc is 2.1 times 10 to the 3 newtons. The mass is given, 12 kilograms. We don't know v, but the radius is given, 0.65 meters. So now all we have to do is solve for v squared. We multiply both sides by 0.65 meters, divide both sides by 12 kilograms, and we find that v squared is 2.1 times 10 to the 3 kilogram meter per second squared times 0.65 meters over 12 kilograms. Kilograms cancel, and we're left with meters times meters, which is meters squared over seconds squared. So v squared has a unit of meters squared over seconds squared. That makes sense. To get v, we have to take the square root of each side. When we take the square root of the numbers, we get 11. The square root of the unit, meters per second. So the speed is 11 meters per second. Now the key to being able to analyze centripetal force problems is to figure out what's supplying the centripetal force. In this case, it's the tension in the rope. In other situations, it will be other things. Find out what's supplying the centripetal force, and then generally, the problem turns out to be pretty easy.